this is how.
Hey guys, so this is the video for Pinch a Light. All you need, it's a really simple experiment. All you need is some paper tape and an LED, so one per child, and one of these little 3-volt batteries, one per child as well. For this lesson, you're kind of talking about, this should come after conductivity. So you're talking a bit about electricity, but they should know it a bit already, and about circuits. You're kind of going to introduce, I suppose, components of a circuit. So the fact that you need a power source, an output, so like your light, for example, and then wires and maybe a switch. So in this experiment, we don't have wires, but all we need to do is pop the LED on so it turns on. Now, there's the positive side of the battery. I don't know if you can see it has a tiny little plus, but also you can just remember the back is the rough side is negative, and your LED is a directional component, meaning if it's in the wrong direction, it won't turn on, but if it's in the right direction, it will. And I'll explain that in a little bit and in the notes as well. So what we want to do is make a little torch, a pinch light, so when you pinch it, it turns on. It's super duper easy. Make sure that they know the long leg of the LED is the positive one, because it takes more length to make a plus sign, is how I always remember. And then the shorter leg is negative. So you just need to have a tiny bit of tape prepared. You can put it onto the put it onto the positive side, take the negative leg up a bit so that it's not touching. Secure the positive side on and really make sure the connection is good, because it can go bad quite easily. And then just start wrapping the tape around. I should do a better job. So now, when you pinch it, it'll turn on. You should have a teeny tiny bit more tape, and made mine a bit short. And once the kids do this, they can decorate them and make them all nice. And then at the end of the class, you can have a little light party or a light show, which is really fun, especially for the juniors. So that's it, really. They can put gems on it. They don't put the gems along here, because you need to be able to push this down. If kids say it's not working, it's probably just because they have it the wrong way around. So just double check. And if just get them to switch it around, and if it doesn't turn on either way, even when they hold it down, it probably means the LED or the battery is broken. So just try and swap one out. Another kind of part of this, so the actual doing the experiment is quite easy. I'll put notes up about circuits and about LEDs and how they work and things like that, because they are, like, the way they're directional is quite interesting. But another little extra, this is an extra little demonstration for the pinch light that the kids wouldn't bring home. But it's still interesting for them to see, and I don't know, it might be it's very senior based for this bit. But let's say you could have your white LED on, and it's on, lovely. You could have your blue LED on. I'm just going to show you if these all work. Prove it. Yellow works, and so does green. Now, if you add the blue and the white, they work pretty well in parallel together. But if you add the blue and the green, the blue turns off, and it still works. It is the green that's making a difference, and the same with adding the yellow. It turns off. So why is that? And there'll be a video about LEDs online as well, but LEDs are they use semiconductors, which is basically there's a small positive and negative cell that are separated a little bit, and you put the current in, and it makes this is why they're directional as well. It means the electrons can jump across the gap when there's enough current flowing through it. But each color is a slightly different chemical, I suppose, different cell. So they require a different amount of what's called forward voltage, but they just need a different amount of current. So the white and the blue have really similar current, so they can both be on. And the green and the yellow have similar forward voltage as well, so they can stay on together. But they just don't work, LEDs don't work great in parallel together if they're different colors. So basically, if you have two different, if the voltage that they need is too different, it'll only power one of them, because all the current will just go to the one that needs less voltage. So it means that the white and the blue need more voltage, need more current than the yellow and the green. And that's just a little bit of extra, something to show them if you wanted to. You can try putting all of them on together to test which one needs the most. I'll add the red too, just for fun. But there will be more notes on this online as well. There you go. So the red can stay on. So you can kind of maybe even test to see, okay, which do you think needs the most and which needs the least, and all this kind of stuff. But the only part of the experiment that I'll actually be bringing home is the little pincher light. Thank you.
Created using Powtoon.